Hi, today we're going to look at relative formula mass, or relative molecular mass, or molecular weight, or molecular mass. There's lots of different ways to say it. Roll the graphic. Welcome back, I'm Paul, this is Science That Sticks. I'm going to talk about RFM, relative formula mass. That's my term of phrase for it, and it doesn't matter what your school teacher tells you, it's the same material, it's the same understanding. Anyway, that aside, here's everything you need to know about relative formula mass. You need to know that you're using the atomic mass number, the big number. In the questions, you will always be given the mass numbers that you need to do any of these calculations. And it will be written as Na equals 23, Cl 35.5, and it goes on. Let's give some examples. Let's talk about sodium bromide. The relative formula mass of sodium bromide will be 23 added to 80. This is so easy, even I can do it. It's going to be 103 gmol. Now, our boy Sean over at Free Science Lessons says that there's no units. You don't have to put a unit in at this particular point, but if you are going to be using relative formula mass in calculations of moles and you want to know where the unit moles comes from, that's where you need it. So I'm going to leave it. The next one is sodium chloride. 23 from the big number, the mass number, added to 35.5, and that gives us 58.5. Again, gmol, y'all. Oh gosh, I'll make myself judder. But that's it. If you can do that, that's free money. And if you're a higher student and you're thinking, well, that's all very well and good, Paul, I can do that, but I'm not sure about how to work it with moles and titrations, don't worry. If you have been given relative atomic mass numbers in the question, calculate the relative formula mass of whatever molecules those elements make up. That will give you at least 1 out of the 4 marks, even if you can't remember any of the other calculations. That's relative formula mass for you. If it's, oh, by the way, if it's an element, which is a diatomic molecule, you use the relative atomic masses and you multiply them by whatever value you have. So in this case, we've got 35.5 times 2, which should be 71. And the noble gases are, of course, just themselves. That's it. Till next time, stay cool. Bye-bye.